If you love space science and astronomy news, check out my 60-second short videos every weekday. In case you missed them, here's all the daily videos in one cut. There was a ton of great stories this week, but of course there's a ton more out there just waiting for you to discover them on your own. Please follow, drop a like, and consider subscribing on YouTube to support the channel and so you don't miss another space science update. Large asteroid impacts like the one that ended the dinosaurs are predicted to happen only once every few 100 million years. Smaller asteroids of 10 to 100 meters impact Earth every few years, but our ability to detect these asteroids in our solar system is poor until they're very close to Earth. Now, researchers from MIT have found that a method used for detecting faint objects in images called shift and stack can be used to detect these asteroids. The astronomers have worked on the search for planets around other stars and wondered if that data, where the asteroids are just a nuisance, could be repurposed. Searching the images is quite computationally intensive, but it turns out modern GPUs are well suited to the task. Originally expecting to find just a few asteroids, if any at all, the researchers discovered 138 small asteroids and are now looking to apply the technique to more data. For example, JWST could be coincidentally observing thousands of these asteroids as part of other programs, allowing scientists to build up a detailed picture of these smaller objects. The research is published in the journal Nature. Have you ever thought about how we know the distances of stars and galaxies when we can't exactly roll out a 40 trillion kilometer long tape measure? That's just the distance to the nearest star. Astronomers use a variety of objects and techniques to build a ladder of distances, with each rung on the ladder building and checking on the ones before it. Variable stars are a key part of this distance ladder because the regular pulsations of these stars give a very accurate measurement of their true brightness. If we measure how bright they appear to us, we can get an accurate measurement of how far away they are. New research has combined Hubble Space Telescope data with observations from James Webb to confirm that both of these observatories agree with each other on the distances to nearby galaxies. These local measurements give us a different picture of the expansion of the universe than the one we get on much larger scales, for example, by using the cosmic microwave background. This so-called Hubble tension has been around for a while, and astronomers are working to try to understand where it comes from. The latest work suggests that maybe there's something missing from our model of the universe, rather than inaccuracies in the observations causing the trouble. Would you have guessed that a violent storm on the sun could cause agricultural chaos? Well, that's just what happened back in May. While we were enjoying the most amazing auroral displays in decades, farmers across the US were tearing their hair out. That's because modern farm machinery is heavily dependent on GPS for its operation. For example, planting amazingly straight rows of crops over huge distances. The accuracy required for this is down to the foot, and solar storms like the one that gave us the aurora caused turbulence in the ionosphere, affecting GPS signals from satellites. The disruption to GPS caused farm machinery to lose its position and start acting erratically, skipping rows of crops and requiring manual intervention from farmers. This may sound like a small issue, but at certain times of the year, a delay of a day or two in being able to perform tasks on the farm can significantly affect crop yields. The next generation of farm machinery will include artificial intelligence, machine vision, and other systems to reduce the reliance on GPS. For now, it doesn't seem like there are any easy solutions to protect farm machinery from a very active sun. Imagine a telescope with 100 times the field of view of Hubble. That's the Nancy Grace Roman telescope. Over its 5-year primary mission in space, Roman's 300-megapixel infrared wide-field instrument will survey huge swaths of the sky, capturing the light from billions of galaxies and trying to explore the nature of the dark universe, black holes, stars, and galaxies. Its other instrument, the coronagraph, will search the Milky Way looking for exoplanets. A coronagraph is an instrument that blocks the bright light from a star to allow astronomers to more clearly see objects around the star. Roman's coronagraph is a test of whether this technology will allow us to directly detect exoplanets around distant stars. NASA has just reached a milestone with Roman, having finished integrating the two instruments and the telescope on the instrument carrier. The payload is now complete, and the team at NASA Goddard can integrate it with the spacecraft. Roman will be carried to space on a SpaceX Falcon Heavy rocket sometime between October 2026 and May of 2027. For more on the latest developments and details on the mission, head over to the NASA Roman webpage. Jupiter's moon Io is the most volcanic body in the solar system, with around 400 active volcanoes. Io orbits Jupiter every 42.5 hours, and the gravitational force it experiences varies with its distance from Jupiter. This causes the moon to flex, which heats the interior so much that parts of it melt. There's been a long-running debate about the nature of Io's volcanism, and new results published yesterday based on data from NASA's Juno mission appear to have finally solved the mystery. One theory was that there's a shallow ocean of liquid magma below the surface of Io that feeds all the volcanoes. The other theory is that each volcano has its own separate local magma chamber. Based on flybys by Juno, scientists were able to determine that the gravitational signature of Io corresponds to a mostly solid interior, meaning there's no shallow ocean of magma, and the volcanoes are a localized phenomenon. The result, which was published in Nature yesterday, has big implications for other moons that experience tidal heating like Europa and Enceladus.